Okay. We've been pecking away at starting concrete walls on the solar array. So we're going to do a catch up video. We got a different guy taking the pictures, and well, he's got the camera turned the wrong way. He's in portrait view, and I imagine he's taken 2 or 3 days of pictures I haven't looked at, and they're all probably this way. Uh, it shows me what I need to know, but it's not as good for making videos because it doesn't fill the screen up. What you're seeing here is you're standing in the feed storage room for the fish tanks. This middle part is a mini machine shop. I need to put together a CNC machine to carve all the doors. I need 26 doors for the house. And I thought I might carve a styrofoam version of a sports car and put glass on it, and then slap it over top of a Toyota chassis and give us something to run around in there that doesn't weigh much. And I also might put a flat DC motor on it, since we're going to have all this solar power. No problem at all to charge the battery. And we only would go 56 miles to Manila and back. And you don't use any electric while you're sitting still in the traffic, so it's just the kilometers. And the whole island's not so big. We haven't got the range to go from our site to any point on Luzon and back. What this is showing us is the uh, going around a corner. I don't like to have just a little anchorage on where my bars make a turn. So we go at least 2 feet into the next direction, which makes this a bent piece of concrete. But it's one solid chunk of concrete with rebar in it. It just happens to make a turn. And the turns make it stable in case of an earthquake. You can rock back and forth, but with this many dowel pins, because these are bent up from in the floor. They're like 8 feet of in the floor, left to right. One left, one right. So it's not likely to slide, just rock. Another example of a corner. You see that bar goes better than 8 feet both directions of the corner. And this is a tall corner. This wall is probably going to be, well, not tall compared to the house, but compared to garden walls, it's no 10 feet, something like that. But it's not like at the house wall, but it's tall enough that I want a pretty substantial corner. Okay, this is the dirt mound we were carving away. Rather than having to carve 16 feet straight back there for that machine shop, I said, well, why don't you just shove the whole pad forward down the hill? Just slide it across the rice paddy. It's already flat. You haven't got to dig all that dirt out of the way. We're going to backfill that to keep that wall cooler, because the powerhouse is in there. I don't want any temperature higher than I have to for the electronics. So just slide the whole thing downhill. Well, they were supposed to go 10 feet past the dirt to start. And what they did was they started at the dirt. I'm not sure how that worked out. This is the first time I've seen that they poured the slab with dirt hanging out of the top of it. But they're going to have to cut all that off and get it out from under there with these bars already in place. So, it'll bring on more talk. But as you know, these guys try really hard and they're working out in 100-degree heat. So, but anyway, things don't always go right. There's one that didn't go exactly according to plan. Okay, they're coming farther up on the corner. This is the northwest corner. The dirt pile hanging out, well, it was right there. Looks like they've took it away. This is showing you how far these bars go down the wall for the angle. Also, it's like tearing paper. You get a crack or ripping a piece of paper near an edge, it's easy to tear right across it. That's how they tear telephone books in two with their bare hands. They're only tearing a page at a time. Anyway, we have more bars near the bottom, and then we have, boy, I can't remember. I think it's 10-inch spaces, but it looks like it's less. They're all the same all through the house. Everything that we poured has this same spacing on it. Now, because this is a slip form, the concrete's going to end at 4 feet on the first pour. That'll be 1.5 inches above this top bar, 1.5 inches cover on the concrete. The next ones to start out, we'll start out with this same thing, and it'll go up 3.5 feet. These are set up with what we call notched boards. We cut notches in the edge of a 2x3, and we just stand them on end, like you can tie them to one of these upright bars, and you just chuck your horizontal bars in there, and they're all level all the way. You see how straight it is, you know, down here, how straight it is going that way. Even just slapping it in there, it comes out pretty neat. But the floors are done in notch boards. The walls are done in notch boards. I'm kind of thinking that after the 20 columns are poured, everything is notch boards. The tie beams, top and bottom tie beams, they had notch boards laying across some sawhorses to space the stirrups, because they're closer spaced near the ends than they are for the long run. If you want them on a geometric progression and working where you can't speak the language, notch boards will do it for you. You lay down a couple boards, you run the saw across it where you want the notches and a couple saw swipes in between, and break it out with a screwdriver. We're using the same notch boards back to 2015. Well, there's our dirt missing. They're showing that it's gone. That would be boy. And he's running bars down this whole thing. I'm not sure what this 2-inch deviation is, unless the bar sticking up out of the floor are got a 2-inch bow in it there. I can understand how the top can lean, but the bottom of them is stuck out of the floor, and you would think they used a string on that. This might be something to do with the camera lens. But this bar on the floor doesn't look bent. I'm not sure what that really signifies. But it is what it is now, because there's 100 and some bars sticking into the floor. But if you're doing tanks and stuff like that, like the shrimp tank and the fish tank, it keeps the wall pretty tight against the floor so you can seal it. You have to hold water. Yeah, there's definitely a kink in it. So that's only going to be about 1.5 inches from the a cover on that instead of 3.5. So it is what it is. And you can see the he's going back and putting all the extra tie wires in there. But you can see that they end up with a pretty neat job without much effort. And adding some tie wires to them, putting tie wires now. If we wanted to have them perfect, we would tie wire about every other one as we put them up there. And you can make it as neat as you want it to be with that method. But that's all the neater it has to be to satisfy me, so that's what we do. Okay. There's going to be a window vent here. We're using the big window from the house. If I don't want to build up air pressure under the solar array, because we have a very windy site. The top of the house is supposed to eventually have a wind turbine on it, vertical axis turbine with booster plates. I don't know, 40 kilowatts or something like that. But we're going to put a 33 kilowatt solar array down here just because we can just buy everything. And I'm not over there to build the wind turbine. But I can send them solar panels and inverters and all kinds of switches and breakers and isolators and battery management system. Just order it out of China and have it dropped on site. And then I'm going to do videos from here showing them how it goes together. They're not real great on reading technical drawings, but if you can show them a thing in your hand and point to where you want the wire to go, not a problem. And plus, we have 2 or 3 of them that worked with electricians on the house, and they're familiar with pulling wires into pipes and how much to strip off and how to put it under the screws and all that. So the only difference is that we're soldering these forked connectors on all the wires and receptacles and switches, because stranded wire doesn't wrap around a screw worth a damn. It looks bad. It's hard to keep it from shorting out to something else. And you're only catching part of the wire. The tighter you make it, the more wires pop out from under the screw. You wrap them around the direction you're going to turn the screws the best you can do, but it's not good enough for me. So I'm going to put these fork connectors on. They have the tips bent up. So if the screw's loose, the wire doesn't slide out from underneath of it. It might arc and weld itself on there, but as far as getting out and shorting out and hurting somebody, it's not going to do that. Anyway, we'll see. This is an error. They're going to have to cut some of this apart down here. Cut these 2 bars and then bend these other ones into the shape of the circle for the window. I'm not sure exactly. I think what they did is they probably went and measured up at the house how high the windows were mounted in the walls in the house and just copied it. But this bar at the top up here, that's the top of our concrete wall. It's a 14¼ angle, 14¼ degrees, latitude of the site, facing south. So that would be really thin on concrete at the top. It would crack for sure. So if they have not poured this yet, then we'll just have them lower that. It take half a day probably, because the forms are up by now. And if they pour it, they won't pour the second 3 feet. And I can have a window that's round on the bottom and angled on the top. I can leave a space for a concrete beam and come back and make a third like a beam on the top down there. It'd be more time, less materials, more time. Just an inconvenience. But we've got a long way without screwing something up on this. So this couple little things we're seeing today, yeah, they're not typical. If they were, I'd still do it. That's another view looking out at, this is the east side. This is the opposite side. All these bars sticking up over here, that's where the shrimp tank goes. We're going to pour it deeper than we need for the shrimp tank. We're going to pour it with 6 feet of water and plus some freeboard at the top. Probably a 7.5-foot wall, something like that. That would be the 4-foot pour and a 3.5-foot pour. That's our standard slip form pours. For the bottom is always bigger, because the bolt holes go through the wall and using the same form. So the forms are used up a little bit, covering up the previous wall. In any event, you can see the shrimp tank is a fairly long thing. It's only about 12 feet wide, but it hangs out there a good ways. And also this one here, the window needs to be lowered. Vent, it's a vent. There's no glass goes in it. We're probably going to put a security grill in it. I couldn't tell you why. Other than the fact that there's not much space between the solar panels and the surrounding concrete. But if somebody's going to steal something, they don't care about breaking some of it if they can get a good bit for themselves. I just want to keep people from messing around here. This thing is 336 volts. That's enough to hurt you. This would be the vent window. This is the door into the thing. And that's Villa Cecilia. I sure hope it hasn't tilted that much in our absence. Wouldn't that be a bitch? It's probably what the camera does. I'm pretty sure the house is level. Somebody would have told me if it wasn't. And it wouldn't all settle that even. It's a massive piece of concrete. in progress of digging what should have been dug before they poured the floor. That's Boyette. He's making some kind of concrete rebars. I'm not exactly sure where he is. Oh, he's in the main kitchen of the house. This form makes the toe board. And this is the space for the dishwasher. And that's an outside door right there. I like a door coming into a kitchen so I haven't got to carry stuff all through the house. And